Great. Welcome again, everybody. It's great to be here with you. Thank you for giving up part of your Tuesday morning here. Hope you had a good weekend and are ready to get into R. So I'm really pleased to be here. I'm Andy. I'll be the instructor, and I'll introduce my colleagues here in just a second, but good to see you all here. So I put the link to the slides in the chat window, and we'll do intros in a second. Let's just get right into it. Okay, so a little bit about me. So I work for UC Ag and Natural Resources, as do many of you. So, but this is a public workshop, so there are a few people who may not. But anyway, ANR is part of the UC system. We are the branch of the UC system that has cooperative extension offices all across the state, field stations, clusters of faculty on 5 of the campuses, and a whole bunch of statewide programs. I work for IGIS, that's the Informatics and GIS statewide program. And this is us. Shane Fryer, my colleague, is here with us today. We are a smallish group within ANR, and this is what we do. So we are Geospatial Support Unit. We do all manner of GIS service projects, everything from little maps for publications to flying drones to helping our researchers find data and analyze spatial data, developing mobile data apps and so forth. So any of that stuff, feel free to sign up for office hours or let us know. We're here to serve the ANR network, absolutely. We also teach workshops. This is just a handful of our workshops. If you go to our training page on our website, you'll see our schedule for the spring. We just got it up there the last couple of weeks. So these are some of them. I'm not sure if we have field maps scheduled yet, but all of these other ones are already there. Drone Camp is our flagship summer workshop. It's going to be the last week of June. If you're interested in learning how to make maps and collect research data with drones, check that out. And we have office hours, so that's a good way to get in touch with us. This is our team up here. Maggie Kelly's our director. You can see the other folks here. So we love what we do. We love working with our colleagues. So please get in touch if we can be helpful. And a little bit about you folks. So I see a good number of folks here. So this is from the registration. So you can see this is all .edu email addresses. So we have a lot of academics. That's great. And you can see quite a few from the ANR campuses and UCANR.edu. So that's absolutely who we were hoping to get here. Many of you are taking the workshops that are going to start next week on statistics. So that's appropriate. And that's so for those of you who don't know, we're starting a series of workshops on statistics for ANR researchers starting next Tuesday. And those will be going on once a week for 7 weeks. Emilio Laca, who's with us today, will be the lead instructor on that. So we're not doing stats today, but if you have questions, feel free to bring them up. And then Jody Azulai is also with us today. She's also going to be helping to run the statistics workshop, as will myself. And where you folks are coming from, you can see it's pretty much scattered all across the state and the country. So that's great to know. So welcome, everybody. Before I go on, though, let me pause here and introduce my colleagues today who are helping us out. So Emilio, do you want to say hello to folks?
Hello, everyone. Look forward to being able to help you. Just send me a chat anytime if you have a question that you want to deal with individually, and we'll make a breakout room and handle that. Good to be here. Thanks, Andy.
The recordings for the statistic workshop series will also be posted when we're done with the whole series. So those will, and as well as all the materials. So, and yeah, today's workshop is a good preparation for that because that series will be using R quite a bit. Yeah, I'm also assisted here today with Shane Fryer. Shane, do you want to say hey real quick? you on the spot.
Yeah, I just want to say welcome everyone, and I look forward to being here if you guys have any questions or need help. And I should also mention, Andy, that Robert Johnson's also on the call.
Oh, thank you. Thank you, Ari, and Robert. So Robert's also part of our IGIS group.
Welcome everyone.
Okay, all right, let's keep going here. So what is our hope today? So this is a workshop for beginning working with R. So the goal is to get you in that direction, becoming more comfortable and functional with R. And really, it's going to be fairly hands-on. The strategy that we'll be using here today is to try to go over some of the language and some of the concepts in working with R. R is fun, it is a programming language. So it helps, there's a lot of documentation, there's a lot of good tutorials, but knowing some of the vocabulary is really helpful. So I'm going to be hammering home some of the terms that you're going to see in documentation and tutorials and so forth, right? So some of that foundational stuff, a lot of hands-on practice today. We'll get there probably in about 10 minutes or so. We're going to be working with RStudio. So RStudio has lots of convenience functions, lots of bells and whistles that make working with R easier. So I'm going to try to highlight those as we go along. I think you're going to like it. And then finally, how to get help, right? How to help yourself figure things out, because nobody has memorized all of R. We all use it, even those of us who are using it day to day are constantly referring to the help pages, finding resources online and stuff. So we're going to cover some of that as well. So if I had to break today's topic into a pie chart, it would look something like this. It's going to be a lot of coding practice, right? I want you typing commands at the R console, making mistakes, and just getting comfortable with it, right? Could spend a whole hour talking about R, why it's such a wonderful thing, the history of it. We're not doing any stats today. Come back for next week, so that's going to be separate. And we'll go through some of RStudio, but really it's going to be fairly hands-on. Okay, so I'm going to try to get right. I think 90 minutes is going to go pretty quick, to be honest. There are some other workshops going on this week and coming up. So this is part 1 of this workshop series on getting started with R. Part 2 will be Friday at the same time. Hope you can make it. I'm recording these as we saw. I also will have drop-in office hours tomorrow afternoon. So that's Wednesday, February 23rd, 1 to 3 p.m. Same Zoom link that you're on right now. Just pop in if you have any questions, maybe about your project, maybe something that we're covering today that didn't go well. And then starting next week, there will be the statistics workshops. I also want to flag the Getting Started with R resources that I think I sent out by email. I'll put that link in the chat window right here. There's a lot of resources on the internet for learning how to use R. Everything from little videos to MOOCs, sort of like short courses. You just have to kind of dive in, right? It does help in the beginning to have someone walk you through some of the stuff as we're doing today. But that's what we're here for. So yeah, so lots of stuff coming up. Okay, and I'll just Shane and Emilio, if you feel free to chime in here at any time, right? If I'm going too quickly or have something else to throw in there. Okay, so just a second. Oh, go ahead, Emilio. You good? Okay. Yeah. I'm not generally looking at my Zoom stuff, so just unmute if you want to pause me. So just a couple words about R and RStudio. So R and RStudio, they're not the same thing. R is the programming language. R is the program that we use to work with R, right? But why is R so popular? It is fundamentally an open source language, so that one of the benefits of that means it's free, right? So a lot of people have adopted it because it's available. It has a huge user community, particularly in academia. There are many fields where R has just come to dominate. Certainly statistics, ecology, bioinformatics, not all fields. Some fields like engineering are going with other programs, software programs, but R has definitely made big inroads in academia. So then that's partly why it's so well developed. There are lots and lots of add-ons or packages, and these extend the capabilities of R. I have another workshop series that I teach on working with spatial data in R. So there's a handful of packages or add-ons that make R a really good platform for working with spatial data, doing spatial analysis, spatial statistics, making maps, all that stuff you can do with R. R is particularly strong in plotting, so various graphs and charts that you can make with it, as well as reporting, right? So it is a markdown language. These slides that you're looking at right here, these were created with R. I have a lot of friends who do everything with R, a lot of faculty who do all their publications in R, right, in this markdown reporting language. Once you figure out how to work with R, it's actually fairly efficient. It's not efficient in the beginning, right, because you're learning how to use the commands, how to write scripts, and so forth. But once you get over that hump, there's definitely gains to be had. Something else that R has done really well, and I think this is why it's really gone viral with academics, is that they've made it really easy to get your code out there. So maybe you write a paper, right? Maybe it's a new model for, of a statistical model or financial statistics or something in ecology. You can publish your statistical algorithms through R, and it makes it really easy for people to use. That's kind of how I got started in it. I was in grad school. I started grad school in 2000, which is just about when the earliest versions of R came out. And I had no interest in working with R at all. I was very comfortable with SPSS and other programming languages. I remember when I first saw, notice about R, I thought, well, that must be a typo because that's not a name. But a few years later, my advisor suggested, if you want people, I was developing an algorithm to analyze animal movement, and he said, if you want people to use your method, you have to make it easy for them to use your method. And that's what I did. So I got my algorithm published as an R package, and it's been well used. And it's just a general solid programming language. You can do a lot with R. This is for power users. We're not going to touch on this today, but you can download data from websites and databases. You can create decision support tools. It's just a good programming language. Maybe I could pause there and ask if anyone else has something about R that they find helpful in their work.
Well, Andy, I think one of the things I've noticed is when I thought of R originally and heard about it, I thought of it only as statistics. That's all it was for. And the more I've delved into it, it's like, oh my God, it's so much more of a developed language than I thought it was. And it's like you were saying, people are using it, developing new packages and everything. It's actually quite well received, and there's always someone developing something new for it.
Yeah, that's right.
On that line, if I may make a quick comment, Andy, and I'm going to misquote, but more or less the situation goes like this. There was a big meeting about R and about the benefits of R, and someone said, well, it can't do everything. I said, well, it can do pretty much everything. Well, it cannot order pizza. And a little time later, somebody had written I think a shiny app that could order pizza all night.
That's a good one. Yeah, well, I think the essence of it, as an open source language that's been well developed for a user community to go and run with it, I think that's partly why it's gone well. And Python is in the same boat, right? It's also a great open source product. Yeah, so I hope you're gonna like it. Okay, so we're gonna jump right now. I'm just gonna dive right into the waters. We're gonna go into RStudio. I mentioned before, RStudio is the program that you use to work with the R language. So you don't have to use RStudio. There are other programs you can use to run R. But a lot of people like RStudio, and I think you'll soon see why. As we go along, some general tips for picking up R. Depends on your learning style, but I would encourage you, to take notes. However you want to do that, pen and paper in a note tab or something like that. And yeah, just learn as you go. Okay, so everybody fire up RStudio. So I trust you've installed RStudio. There were a couple emails that went out about that, as well as there's a page on the website. Guide you through that. If you haven't done that at all, I would, at this point, I would go to RStudio Cloud, rstudio.cloud, and just create a free account. It should only take 3 or 4 minutes, and then you can start an RStudio Cloud project and start working with R. So what we're going to do for this first exercise, when you open up RStudio, so I've got my RStudio Cloud going right now. Let me close this stuff up. Playing with this before. Okay, so when you open up RStudio Cloud or just RStudio Desktop, if you're working on your computer, it's probably going to look something like this, right? So you've got various windows. The big one, which is out on the left side, is called the console. You may or may not see a script window above the console, but you should definitely see that console down there. And then over on the right side are some other windows or panes. We're going to look at these later. I'm not going to play with these right now. So I'm just going to move those over. Let me make my window just a little bit bigger right here. So for the next 15 minutes or so, basically, I'm going to be typing code here, and I'm going to ask you to kind of watch it. I'll speak through it. So try to arrange your desktop environment so that you can see the screen share as well as see your RStudio, because I want you to type as I type, basically. Okay? Charles, unmute yourself for a question.
Hey, Andy. I don't see anything that looks like that. It's asking for a new project. Should I be starting a new project to get a screen that looks like yours?
Good question. Yes, start a new project.
Okay, thank you.
Sorry, I skipped that. Anybody else? Okay, let's keep going. Okay, so one way that you can think about R is that it's just kind of like a fancy calculator. So at the console, you'll see that little greater than sign. Just type a mathematical expression like 3 times 7 and hit enter. Okay, so that's one. Yeah, so go ahead and type in a couple mathematical expressions, hit enter. So like any program where you're typing in mathematical equations, you have to remember the order of operations. So for example, 3 plus 5 to the power 2. You might remember from school, from algebra class, or from Excel or Google Sheets, that R will evaluate exponents before it'll do the other operations, right? So the notation there is, I think it does parentheses, exponents, and then multiplication and division, and then addition and subtraction. Okay, so so we have a good comment in the chat window. So if you type an expression, I'm going to type in here 3 plus and then hit enter. So if you type in an expression and you hit enter, but you didn't finish the job, right? So it's saying 3 plus, but that's not complete. I need to add a second number in there. So when you see that plus sign, Jeff, that just means whatever you just typed wasn't a full expression that it can evaluate. It's waiting for you to finish, so you can just type in the rest of your expression, and then it'll spit out the result. Okay, this is extremely common. These are easiest to figure out. You can say, okay, I forgot to put a number or something, but sometimes you forgot to put a quotation mark, or you forgot to put a parentheses. So whenever you see that plus sign at the cursor on the console, you have to look up and try to figure out what did you not finish. Okay. Excellent. Okay. So remember the order of operations. So parentheses come first. So if I say 3 plus 5 and then raise that to the power 2, it's going to do the 3 plus 5 first, and then it's going to raise it to the power of 2. Okay, this should be pretty standard stuff, right? Okay, so that's an example of some simple mathematical expressions. R also has some constants that are built in. So type the word pi, Pi, hit enter. That is a constant. So that's the value of pi. Okay, so that's one way that you can use R, but obviously this is not very efficient, right? Because we would have to retype these expressions if we want to use them again. So it's very standard in all programming languages is that we save the value to variables or objects. So I'm going to type in here x equals 2 times 7 and hit enter. Okay, now notice something different happened, right? It doesn't show us the value of x, right? We're not seeing 14, but we are basically have created a new variable. And in fact, if your environment pane is open over on the right, you will see x as a variable or object that is in memory. Variable and object, I use those terms synonymously. I'm going to use the term object more frequently because these are numbers. And, when we think variable, we often think that stands, for a number, but object is a more general term. And later on, we'll be saving things which are not numbers. Okay, so we just created an object called x, which equals, now if you want to see the value of x, you can type the x by itself and hit enter. Okay, so when you are creating an object and giving it a value, R will not show you the result at the console. But if you want to see the value, you can type the name of an object by itself and hit enter, and it'll return the value. Let's create another object called y. Say y equals to, say, maybe 3 plus 4. Again, we don't see what y is, but if we hit y by itself, we get the value back 7. Okay. Let's keep going. All right, so we now have x and we have y. Yeah, that's right, Jeff. You might wonder if white space is important, and the short answer is for things like mathematical expressions or formulas, white space is ignored. I am putting spaces, around the equal sign and the plus sign, but that's just for readability. They're optional. Okay, so we have a object called x and an object called y. We can type x plus y and hit enter. So when you have objects that you've defined in memory, you can now use them in subsequent expressions. Okay, I could type x plus y to the power 2. I can even assign, I could say z equals x plus y to the power 2. All right, so now I've created a third object called z, and I've assigned it the value of x plus y to the power 2. If I want to see what that is, I can just type z by itself, and that's going to be 63, because again, it does the exponents before it does the addition. Okay, we'll keep going. So now I've got a variable called z. I can also reassign z a different number. I can say z equals 32, and now z has the value of 32. So you can change or update the value of objects by just reassigning them a new value. You can even do this, which is a little strange. I can say z equals to z to the power 2. So z equals z to the power 2. If this was algebra class, that wouldn't make a lot of sense. But this isn't an algebraic equation. Here we're using the equal sign to give z a new value. And if I type z by itself, now I can see that the value of z is 1024. Okay, so that's an example where we are updating the value of z by assigning it an expression which actually uses the first value of z. Okay. Any questions? All right, so we're doing some basic, we're just playing around with the syntax. Okay, next, let's look at some comparison operators, right? So type Z is greater than 5 and hit enter. Okay, so the greater than symbol or operator is a comparison operator, and it's going to return true or false depending on if Z is greater than 5, but Z is much greater than 5, so that equals to true. We can see some other examples of that. Maybe is X less than 14? False. Because X, if we say X is less than or equal to 14, that will be true. All right. All right, so it's the same comparison operators as you would probably see in Excel. What if we were to say, is X equal to 14? If we do that, it doesn't show true or false. And again, that's because the equal sign is assigning X a value. It's not a testing for the equality. If you want to see if something is equal to something, you have to use the double equal sign. So X double equal sign equals 14. That will compare X and 14 and return true or false. Okay, so those comparison operators, greater than, less than, double equal sign, they return true or false. Okay, and of course, you can write expressions like you could say X equals to Y times 2, Y equals to 7. So again, that evaluates to true. So R runs that, and it sees is the left side equal to the right side, and it returns true or false. Okay, so far what we've been doing is we have been using like X, Y, and Z as the names of our objects, but you're not limited to single letters. I could say, for example, X1 equals to 22. So object names in R, the rules for naming objects in R are pretty flexible. You cannot start with a number, it has to start with a letter, but beyond that, you have a lot of flexibility. I'm going to define one here called shoe size equals to 14, where I've capitalized S, the two S's, right? So that's an example of, that's a style of naming objects, which is popular. We use upper and lower letters to make it more readable. That's called camel case. Shoe underscore size equals to 9 is another example. Right? So that's another way that you can name objects is with underscores. Let me try shoe hyphen size equals to 8. That doesn't work. So you cannot have a hyphen as part of the name of an object because R thinks that's a minus sign, right? So that's one thing you can't do. But you could do shoe dot size equals to 8. So the periods can be used in object names. Okay. If I type, the one thing to note though is that R is case sensitive about everything. So if I type shoe size, and hit enter, oops, you'll see it's got the, you're probably getting autocomplete. So autocomplete is one of the features about RStudio that is usually helpful. Basically, as you're typing, it'll look up to see if there's a object with the same name or a function with the same name, and if so, it'll give you that autocomplete box. And if you want to accept their suggestion, you can hit tab. But this shows us that R is case sensitive. So this is another gotcha, right? So sometimes you'll see an error message that says, this function not found, this object not found, it could be a capitalization issue. So be careful about that. Okay, so we've named some of our objects. All right, good. Some good wisdom from Emilio that it's helpful to pick its style. I would suggest two things about naming your objects. One, use meaningful names, because you might have a script where you have A, B, C, M, N. Very soon you're going to forget what those are. So use meaningful names, and as Emilio recommends, pick a style that you like, either that upper lowercase or with the underscores, but save yourself a bit of work.
And I would agree with both Andy and Emilio on this one, and that is that if you need help from someone else or you want to share your code with someone else, using meaningful names is very helpful. Yeah.
Including yourself when you come back to your script, like 2 months later. It's like, well, what is this supposed to mean? Okay, so what we've done, I'm gonna hit the little broom. Actually, no, I'm just gonna hit enter a few times. I'm gonna hit the broom. If you're sharing your code, and some publications will ask you to share your code that you use to take the data that you got out of the sensor and to fiddle with it for your regression, they'll ask you to show that code, or you have the option of submitting your code as part of the supplementary information. So again, your work is reproducible, and that's another reason why using good variable names is helpful. Let other people do your code. Okay, so let's create some more. I just cleared my console here. You will notice, though, if you haven't already, if you look in RStudio, next in the upper right-hand pane, there is a history tab, and that's your command history. So all of the commands that you have run will appear there. The other thing you can do, if you want to go back to a command that you've already entered, if you're at the console and the cursor's blinking, you can use your up and down arrows to kind of scroll through your command history. So that's a bell and whistle that RStudio provides that can save you a little bit of typing. But so far, what we've been creating objects for are numbers and only numbers. So, but we can also work with text. So I'm going to say here, shoe underscore color equals to brown, and hit enter. So one thing to note, if you are defining a object that is text or a character, you have to put it in quotes, right? Double quotes or single quotes, they both work, right? Now, what happens if we say shoe underscore color, and I just hit enter? It gives me my, reports back what the value of that object is. If I try to use that in an expression like shoe color plus shoe size or something like that, and hit enter, I get an error message, as I should, right? How can you add a character like the word brown to a number? That's not possible. So that's an example of an error message. In general, R does a pretty good job of converting objects on the fly as it needs to do like a mathematical expression, but you can't add a word and a number together. It's not meaningful. Okay, so next I'm going to give you a challenge. So your challenge is here. I'll put the challenge in the console as a comment, right? So you might notice what I just put into the console here. It starts with a hash character. I like to use 2 hash characters. 1 is okay. When you enter something that starts with a hash or with the pound sign, that's a comment. So R is not going to evaluate. So even though there's no valid R commands in what I just put there, it's a comment. So your job is to write an expression at the console that will return the area of a circle whose diameter is 10 meters. Ignore the units, whose diameter is 10. Okay, And if you don't remember your algebra, so the area of a circle equals to pi times r radius squared. R radius squared. Right? So that's a hint. So write an expression. I'll pause for a minute here, let everybody do that. But we've seen everything that you need to write this expression, we've already seen. All right, does anybody want to share their answer? Feel free to put your answer in the chat window. The expression you wrote to return the area of a circle if the diameter is 10. All right, I like the one that Emily has put in. So if you all can see what Emily has put in, it's pi times r. Now the diameter is 10, so you have to divide that in half. And you put those in parentheses, so that gets evaluated first, and then squared. I'm going to copy what Emily put here and paste it in my console. Let's see if I get the same thing. And I do. So the correct answer is 78. Probably some of you forgot to divide the diameter in two, but that's okay. It's not a math class. Okay, oh, very good. So John defined some variables, and then he used those variables in the expression. I like that. Let me copy those two. All right. Okay, so one more concept that's important that we'll kind of wind down here on is that we've created a whole bunch of variables, right? I'm going to click on my environment tab again, and you should as well. And the environment tab basically shows what do you have in memory? What objects have you created that are in memory? And it's really nice because not only do you see them, but you also see what their value is in that environment tab. So all objects that you've saved in memory have a class. So and you can find out what the class is, the name of the class, by using the class function. So I'm going to type the word class and then parentheses, and then I'll type A and hit enter. Okay, so class, and then in the parentheses, I put one of my objects that are in memory, and it's telling me that is a numeric object. Not a big surprise. Let me do the same with shoe color, because that's a little different. And I'm going to use my Autocomplete function, and that's a character object. So what we're working with today are mostly numeric objects and character objects. There are other objects that we will be working with, including like dates. A factor is another one, but these are some of the common ones. Okay, so before we go back to the slides, I'm going to enter one more command, and this is kind of a teaser because I know this is kind of boring, just like looking at these little commands. So I'm going to type the word hist, and then in parentheses, I'm going to type a function called rnorm, and then in parentheses, I'm going to put in a big number like 1,000. And you should see, now I'm going to stick that, because there's a lot of parentheses in it, I'm going to stick that in the chat window, just for convenience. So I just put in the chat window the final command that we're going to look at in this little exercise. And this is more of a teaser, but you can kind of see what it's doing, right? So hist is a function that makes a plot. And in RStudio, that plot will appear in the plot pane, which is on the lower right. And inside the parentheses of hist, I put another function called rnorm, which returns random. So the R stands for random, the norm stands for normally distributed. So basically it generated 1,000 numbers that are normally distributed around 0 and then made the histogram of them, right? So we'll see, we're going to see some more plotting coming up, but that's just a little bit of a teaser. Okay, we are done with that exercise. So I'm going to go back to the slides. We'll take a break in just a couple of minutes. Okay, we'll keep going. All right, go back to my slides. I've changed my screen share here a little bit. Okay, can you see my browser here? Yes, okay. So a
Yes.
question came up during the break about, so we've just created this project on RStudio Cloud. That's in the cloud. So how do you get it back? Or how long is it good for? If you look at the free account, I assume all of you have at least a free account on RStudio Cloud. It's pretty generous. You're allowed up to 50 projects. You probably just created one project. You get up to 25 project hours per month. So that's time that you're spent working on your projects. So it's fairly generous. There's probably an upper limit like on how much files that you could save on your RStudio Cloud. Maybe you have these ginormous CSV files that you want to work with. You can upload files to RStudio Cloud. But it's all I can say would be that it's generous. I don't see what the thing here is. There are some limitations on the amount of RAM you have. That's not going to be an issue for modest kinds of work that we're doing. And if you do want to, say you have a script, actually we haven't started working with scripts. So when we get to working with scripts, I'll show you how you can download the scripts that you've worked. So far, all we've done is type things in the console. But that takes us to the next bit, which is going to be working with scripts. Okay, but quickly, let's do a little review of what we just went through. So we saw that when you type expressions at the console, R will evaluate them and give you the results back. Remember the order of operations, parentheses, exponentiation, multiplication, division, and then addition and subtraction. There you go for that. If you enter an incomplete expression, you will get that plus sign that's prompting you to finish it. Okay, that could be a number, it could be a parentheses that you have to close, could be a quote. Saving the results to objects is really standard. We've been using the equal sign to save the results of expressions to objects. There's another operator, which is actually two characters. It's the less than and then the hyphen. That's called the arrow operator because it kind of resembles an arrow. You see that a lot in people's code. So if you see it, don't be surprised. You can just swap in. You can swap in an equal sign there when you see that. It's doing the same. Okay, so the R objects are can be named anything. Just don't put in spaces and don't put in hyphens. Don't start with a number. R is case sensitive about everything. That's a common gotcha. You might think something's wrong, but you may just have the wrong case. Once you define objects, you can use them in other expressions. You can update them. Remember that the objects that you're creating when you're running commands are only in memory. So when you close RStudio, you need to, next time you come, they're probably going to disappear. There is an option to save your workspace. So next time you open RStudio, they're back. But probably another and maybe a better method is to always save the commands that create those variables so that you can repeat those commands. Because one of the reasons for using a programming language like R as opposed to Excel is that it's reproducible. Right? So save your commands, which we're going to do next by putting them into a script. Okay, these are the comparison operators. We're going to be coming back to those a lot. And we've seen that constants, R comes with some constants, like pi, right? And you work with those constants just like you work with other kinds of objects, but they're there for you. Okay, so any questions? Okay, we're going to go back to RStudio and we're going to do another exercise. And in this exercise, we're going to put our work into scripts. We're going to start playing more with functions because there's a lot of power that you can get out of functions. We're going to talk about vectors and talk more about data types. Okay, so go back to RStudio. And I am going to switch to RStudio Desktop. Can you guys see my RStudio Desktop? Is that visible?
Yeah, we can see it, Andy.
Okay, perfect. And the reason I'm doing that is because I'm doing something, I'm using a package called live code. I'm putting a link in the chat window there, which is optional, but that link will have the code that I type in my script. Okay, so first thing to do is create a script. So if your RStudio still looks like this, meaning there is no script open in the source pane, which is above the console, then go to File, Menu, New File, and then a new R script. Okay, so create a new R script. All right, and once you've done that, it will appear above the console. You can have multiple R scripts, and they will all be open in separate tabs above the console. Okay. Scripts are just text files, right? So you can save them by convention. You could save them as .txt. The convention is to save them as .r. So go ahead and click Control S or click the Save button, and you probably have an empty script, but go ahead and save it, and then we're going to start typing into it. Okay. All right, so hopefully by this point, everybody has opened up the script. Okay, so scripts are used in all programming languages. It's basically the same stuff that you just typed at the console. You can type those same commands in a script and save that script so that next time you want to do this, you can just run the commands from the script window. So the way to type a command that we just typed, say I have here x equals to 2 in my script window. Now to run that command, you'll notice in the source window, there's a little run button. So that run button, I can click there. And basically what it does is that it copies the line where the cursor is blinking, or if you have lines selected, highlighted, it'll copy those multiple lines. It'll copy them down to the console and run them, right? So you can use the run button to run commands in your script. You can also use Control Enter on the keyboard.
Andy,
Okay.
Can you run through the purpose of the script? It's just my understanding is the script is used to save what otherwise would be in your console, which would be lost. Is that correct?
It saves the commands that are in your console. The other thing that you can do with scripts, though, which we will be doing here, is that you can comment your code, right, in ways that you couldn't do easily in the console. So, for example, I'm going to type in my script right here. And again, you can either watch my the screen share, or you can follow the web page that I put up there in the chat window. I'm going to type in a comment called, let's look at functions. So this is an example where I am writing comments in my script that will help me or somebody else understand the commands in this script. Okay, and that's another benefit of putting your work in scripts. Okay, so functions are an example of a function would be sqrt, which is square root. So type sqrt and then put a number in there, such as 25, and hit run or Control Enter. So that's an example of a function. Another one I'm going to do here is round. So there's a function called round. And as you might expect, it rounds numbers. So round, and then I put in pi, comma 3. And that's rounding the number pi, the constant pi, to 3 decimal places and showing me the results. Right? Another one I could do would be cosine pi, pi. All right, so I can run that. Right? So we're just playing with some of these basic math functions. Let me try another one called R norm. We just saw R norm, you might remember from the end of the last exercise. And I'm going to put R norm, and then I'm going to put in the parentheses the number 5 and hit enter.
Brief question, what may be wrong if it doesn't show it in the console? I enter it into the script, but it doesn't show anything underneath. I don't see the results.
Yeah, so to see the results, or more to run the command that you've typed in the console, you have to hit Control Enter, right? So select the command that you've written and either click the Run button or Control Enter. On a Mac, it's I think it's the butterfly key. I forget what that's called. There's another
Control. I just checked. The Control also works. Control Enter works too.
Okay.
Control Enter and Command Enter will both work in the Mac.
Yeah, that's a good point though. So typing commands in your script does not automatically run them. You have to manually run them one by one. Later on, we'll see a way that you can run them all at once. But for right now, we're going to run them one by one. Okay, so let's pause here because I just typed the function rnorm, and then in the parentheses, I put the number 5. And if I look at what it spit out at the console, it's not like one number, there's like 5 numbers. So these are 5 random numbers. So this is an example of a vector, right? So I'm going to put a comment here in my window. It says some functions return multiple values, right? So we call these a vector, right? So a vector is simply a object that has multiple values of the same thing. It's a collection of alike things. So if I save the results of our norm to a variable called x, okay, so I basically reran the rnorm function with 5 as the argument. That's what goes in the parentheses. We call that the argument. And I save that to x. So now x has those 5 numbers. X is a vector. And if I run x by itself and hit Control Enter, I see those 5 numbers come back, right? Every time you run rnorm, it generates new random numbers. Okay? So basically, vectors are collections of similar things. Let's create another vector. There's another function I want to show you. I'm going to type here z equals seq, and then I'm going to enter, say, 1, 10. And I'm going to run seq 1, 10, and then I'm going to type z by itself and run that so that I see what it created. So the object z now contains 10 integers from 1 up to 10, and seq stands for sequence, right? So sequence, seq, is a function that will return a sequence of evenly spaced numbers. It's it's a very useful function. Okay, so seq is another function that returns a vector, a collection of, in this case, integers. There's another really good function called the C function. C stands for combine, also returns a vector. Let's take a look at C. So I'm going to say A equals to C. And then in the arguments for C are going to be the elements that it's going to return. So for example, this could be 2.2, or comma 4, comma 77, and then I could hit enter, right? So you can put in any numbers there. And then I'll see what does A contain. Okay, so basically the C function is a really important function. C stands for combine, and it basically takes the arguments, the things that you stick inside it, in the parentheses, and it returns a vector with those elements. Okay. Now I said that vectors have to all have the same thing. So what would happen if I ran A again, but I tried to combine some numbers with maybe a word, like a color, right? What is it going to do? If I look at that, it's going to, so if you mix and match different types of values inside the C function, R will kind of figure that out and do the best it can, which in this case is converting the numbers into characters. Right? So that's what happens if you do that. All right. And of course, you can create vectors that contain, that's an example of creating a vectors that contains numbers or characters. Sorry, characters. So I could type another one, say V equals to, or B equals to maybe some ice cream flavors. Okay, so we're creating some vectors using the C function, and vectors are collections of the same objects. Now you might wonder, well, why is that useful? Like that seems like making things overly complicated. Well, in statistics, we're often dealing with a lot of values, right? You're rarely working with a single value when you're analyzing data. So having all of your values saved in one object is really helpful. Let's go back to, I'm going to look at my object called Z. So I'm going to run that. So Z contains the integers from 1 to 10. I could type here Z plus 100 and hit enter. And what I can see is that the plus operator, so the plus is basically adding 100 to every individual element of Z. Right? So that's handy. So plus, let's look at exponentiation. So if I say Z to the power 2 and hit Control Enter, I can see that, yeah, so Z to the power 2, exponentiation is also applies the operation to every individual element of Z. All right. I'll do one more, say square root, SQRT, and then put Z there in the parentheses, and that one also. So many functions and operators in R are designed to apply the same process to every element if you feed it a vector with multiple objects. Okay, that's called vectorization. There are other functions though. Let's use the function sum, S-U-M, and then put in the Z as the argument. And as you can see, as you would probably expect, sum takes the sum. And so that one is not vectorized. That's an aggregate function. In other words, it's taking all of the values of Z, which again are integers, and it's adding them up, right? Giving us back one number. Let's do one more like that. SD stands for standard deviation. I can run that. And again, it gives me not 10 numbers, it gives me one number, which is the standard deviation of those numbers. Okay, so next, let's figure out how to get, sometimes you don't want all of the numbers. You might just want a few of them, like the first 3 or one of them. So to get an individual element from a vector, we can use the square brackets. So I have Z. Z has 10 elements. If I immediately after the Z, if I put in square brackets and enter a number, say 4, and hit enter, so the square bracket notation pulls out a specific element, Okay, in this case, we're getting the fourth element. Okay, so that's how you grab individual elements. You can even update individual elements. So if I say z and then put in brackets 4 and then say equals to 444 and run that. Now if I look at z, I can see that I updated the fourth element of the vector z. Okay. So you can update individual elements of a vector. Okay. You might wonder, well, how would I know? Sometimes you might not know how many elements a vector contains. You can always look up in your environment pane, and if I look at z in my environment pane, it tells me this is a numeric vector and it's got 10 elements. You can also use the length function. So length, and then in parentheses I put z, returns the value of z. Sorry, the number of elements in z. I want to come back to functions. Oh, we're almost out of time. Okay, well, let's finish up on this. So let's go back to the sequence function, seq, and we know from experience that I can put in two numbers, say 10 to 20, and hit enter. All right. So what we put inside the parentheses are called arguments, and the sequence function needs at least two arguments, two numbers, then it's to generate that sequence. So oftentimes you need to figure out how to use a function correctly. So how are you supposed to know that the first argument, what is the function expecting for the first argument? What is it expecting for the next argument? So every function has a help page. So the next thing that's important to know is how to find the help page. So you can get to the help page of a function by typing the question mark and then the name of the function without the parentheses and run that. So again, to open the help page for a function, type question mark followed by the name of the function without the parentheses and run that. And you will see the help page opens up in RStudio. And if you scroll down, a lot of this might look like gobbledygook. But what you can pull out though is at the top of it, under the usage section, it tells you what are the arguments that it expects inside the parentheses. So I can see here that the first argument is the from argument and then the to argument. So that's why putting 10 to 20 will give us numbers from 10 to 20. So far, we've gotten away with just entering the arguments as plain numbers. But I'm going to run sequence again, and this time I'm going to put in the names of those arguments. I'm going to say from equals to 10, to equals to 20, and I'm going to run that. It does the same thing, but it's a little bit different in that here we're putting in the arguments and we're actually giving, specifying the names of those arguments. Now you might wonder, well, why would you do that? It's just extra typing. So sometimes it's helpful to put in the names of the arguments to help you understand what they are. Sequence is fairly intuitive. But suppose we wanted to create a sequence of numbers from 10 to 20 by twos, right? So to do that, we would add a third argument, which is, if you look at the help page for this function, we could say by equals to 2, and then run that. And if I look down at the output, it's, the by argument is tells it, to skip every other number, to generate sequence numbers by twos. So this is an example of two things. One, I can do the same thing. I can omit those arguments. I can omit those names. I can say sequence 10, comma 20, comma 2, and run that, and I get the same thing. So what we're seeing here is two things. One, the by argument, and this might seem a little pedantic, but I think it'll be helpful. The by argument is optional. The default value is 1. If you don't enter it, it's still there, but the default value is 1. So if you're happy with the default value, you can leave an argument out. If you enter the arguments in that function in the order expected, according to the help page, then you can omit the names of the arguments. So those are the two things to remember here, that you can omit arguments if you're happy with the default value, and you can omit the names if you put them in the same order as expected. Okay, let's stop there. And then we've pretty much gone through most of this section, but let me just finish up with a few slides to kind of cover some of the highlights, and then we'll stop. All right, so let me find my. Okay, so I'm back at the slides, and we'll just kind of review what we just went through that section. So functions. Getting comfortable with functions is key to working with R. Most of the power, including the statistical stuff, the fancy statistical stuff, you use functions. So anything that has parentheses is a function. What you put inside the function are called arguments. All of the arguments are named, but you can drop those names if you're entering the arguments in the order and you're not skipping any of them. Right? Some arguments will have default values, and therefore they are optional. We didn't get into piping. We ran out of time, but we'll start on Friday talking about piping. Piping is a way that you can, it's an alternative way of feeding arguments into functions. All right. Vectors. So vectors are collections of like things, like numbers or characters. There are several functions that return vectors, multiple elements. These are some of the ones that we saw. We didn't see sample. Sample takes a random sample, but we'll see that on Friday. You can build vectors from scratch using that combine function. That's handy. A lot of the math functions and a lot of the functions in general are vectorized, meaning they will do the same thing to every element of the collection of the vector. Right? So we saw examples of that. There's some other functions that you feed it a bunch of things and it spits out a single value. Right? So we would call those aggregate functions, such as sum, mean, and max. Every function has a help page. So get used to going to the help pages to help you learn how to use a function, how to understand or know what it's giving you back. We've been working with simple functions, but that'll get fancier. And to get to the help page, you use that help operator, which is the question mark. So I'll end with saying R has thousands and thousands of functions. Most of the time, though, you're going to be using more like 20, right? So check out these cheat sheets. They have the most commonly used functions. And yeah, and we'll stop there. I will stay on for questions. Thank you, everybody, for joining us, and I hope to see you on Friday. And yes, I will send out the recording for today's workshop.